Hello viewers, welcome to my channel. In today's lesson, we'll be learning simultaneous equation using graphical method. So to solve simultaneous equation in mathematics, we have three methods. We have the elimination method, substitution method, and the graphical method. So our focus today is on the graphical method. So this method is used when drawing the graphs of two linear equations. So we have our linear equation to be something like 2x plus 3y is equals to 6. This is one linear equation. So we can call this equation 1. Now when we have another equation like 3x plus 4y equals to 7, we can call this equation 2. So now when we are solving two linear equations, is what we call the simultaneous equation. So this method is used when drawing the graph of two linear equations on the same axis. So x for equation 1 and equation 2 are going to be drawn on the same axis, and then y for equation 1 and equation 2 are going to be drawn on the same axis. So we have finding x and y values where the two lines meet. So the reason for solving simultaneous equation is to find the value of x and y. Is to find the value of x and y. The purpose of solving simultaneous equation is to find the value of x and y. So on the graph, for we to get the value of x and y, they must meet at a point. So let's say we'll have a simultaneous equation like this. Let's say this is the line for the first equation, and then this is the line for the second equation. So at this point where they are meeting, which is also known as the intersect for x and y, so this point where the two equations are meeting is going to give us the solution for the simultaneous equation graph. We have three methods for solving simultaneous equation graphically. So just as we have three methods for solving simultaneous equation itself, now using the graphical method, we also have three methods. So I'll be applying the first method here, which is what I mentioned as method A. Then we'll have our method B and C in the same video. So for method A, this is the rules we have to follow. It says make a table of values for both equations. So for equation 1 and 2, for equation 1 and equation 2, we have to make a table of value for it. Now the next is to draw the graph for both equations on the same axis. Then after that, we have to find the coordinates, that is x and y values, where both graphs intersect. So these values are the solution of both equations. Just like I said that whenever we get the value for x and y, that's where the two lines meet, it is called the solution. So it is known as the solution of both equations. Now the last is check your solution by putting these values into the original equation to make sure they satisfy them. So take a look at number 1, 2, 3, and 4. Now let's apply number 1 for the example we have below. So we'll be working with this example for the three methods. So for method A, B, and C, we're working with just one question. So now after working with this question, we'll be able to compare the graphs to see that they are actually the same graph, meaning the three method can be used anytime, any day. So now number 1, it says solve the following simultaneous equation using the graphical method. So this video is mainly for the graphical method, just like I said earlier. So now we're going to solve just this question: 2x minus y equals to minus 1. And then for equation 2, x minus 2y equals to 4. Now solving this question, we have to apply the rules in method A. It says make a table of values for both equations. That means for equation 1 and equation 2. So we'll call this equation 1. We'll call this equation 2. So now we have to make a table of value. And now I'll work with equation 1 first. So let's call this equation 1. We'll have 2x minus y equals to minus 1. Now my table of value will actually cover for the x-axis and then the y-axis. So we'll rule this. So now we've drawn the table. For equation 1, we'll have our x here and y here. So this is what our equation 1 is. Now whatever we do here, we're going to repeat it on equation 2. So for equation 2, we're going to write x minus 2y equal to 4. So we'll have our x and we'll have our y. So what this means is this: we have to impute a value for x. That's for the x-axis, we have to give it a value. So whatever we do in equation 1, we also repeat it for equation 2. So if we give this a value, now that value we give x, the value we give for x, we are going to substitute it in both equations. So when we substitute it in equation 1, we will use that value to find y. And we're going to repeat that same method for equation 2. So now let's start. Let me impute that when x is equals to -2, we should find y. So the first number I'm going to impute here is -2. So you can actually decide to work with any number. You can work from 0, 1, 2, 3. You can even work in twos, that's 0, 2, 4, 6, or even 1, 3, 5, 7. Or you can do just the negative or the positive part. The positive, I can just decide to work with non-negative numbers, which are 0, 1, 2, 3, 4, So, but here I want to work with -2 first. So I'm going to substitute x as -2 in equation 1. So now let's write the question for equation 1. We'll have 2x minus y equals to -1. So the best thing to do is to make y the subject of formula. The reason why I'm making y the subject of formula is because we are going to fill up the axis for y. We're going to fill up these spaces. We're going to fill it up for y. So let's just make y the subject of formula so that whatever value we give x, we can just simply put it there and find y. So this is minus y equals to -1. When plus 2x crosses equation sign, it turns to -2x. So now we have a minus sign here and we need to make only y the subject of formula. So I'm going to multiply through by minus. So when I multiply through by minus, it is going to eliminate this. So minus times minus is going to give us a positive y equals to, so -1 times the minus outside is +1. Then -2x times the minus outside is +2x. So now we've made y the subject of formula. So now y is equals to 1 plus 2x, which is the same as this equation 1. It is the same, just that we made y the subject of formula. So now let's substitute when x is -2. So y is equals to 1 plus 2 into bracket -2. So y is equals to 1 plus 2 times -2 is going to give us -4. Now we have plus times minus. So y is equals to 1 plus times minus is -4. So y is equals to 1 minus 4 gives us -3. So now that we've been able to get -3 here, in the space for y, we are going to write -3. So when x is -2, y is -3. So now I want to work with when x is -1. Remember we made y the subject of formula and it became y equals to 1 plus 2x. So now when x is -1, y equals to 1 plus 2 into brackets -1. Now y is equals to 1 plus 2 times -1 is -2. Y is equals to 1 plus times minus is -2. So we now have y equals to 1 minus 2 gives us -1. So now when x is -1, y is also -1. So now after -2 -1, the next number should be 0. So we're going to write it 0. I can actually decide to complete this 1, 2. So we have -2 -1, 0, 1, 2. So now I'm going to make when x is 0, let's get the value for y. So when x is 0, so we have y equals to 1 plus 2x. Remember we made y the subject of formula. So now when x is equals to 0, we have to put 0 in x. So y is equals to 1 plus 2 into bracket 0. Y is equals to 1 plus 2 times 0 is 0. Now y is equals to 1 plus 0 is 1. So whenever x is 0, y is 1. Now we're going to look for when x is 1 and 2. Now let's get for when x is 1. So y is equals to 1 plus 2 into bracket 1. Y is equals to 1 plus 2, bracket 1 is 2. Now y is equals to 1 plus 2 is going to give us 3. So when x is 1, y is 3. Now we have to look for when x is 2, which is the last value of x, when x is equals to 2. So it is going to be y equals to 1 plus 2 bracket 2. Y equals to 1 plus 2 times 2 is going to give us 4. Now our y is equals to 1 plus 4, which is 5. So when s is 2, y is 5. Now, just as we did for equation 1, we're going to repeat it for equation 2. We're going to repeat the same procedure for equation 2. So for equation 2, x minus 2y is equals to 4. Now let's make y the subject of formula. Minus 2y is equals to 4. When plus x crosses equation sign, it turns to minus x. Now divide through by minus 2 so that y will stand on its own. So now our y is equals to this negative sign. I would love us to take it up. So it becomes minus 4 plus x equal to 2. If you notice minus, when I bring it up, it becomes minus times everything here. So minus times plus 4 is giving us minus 4. Now minus times minus x is going to give us plus x. Or we can even say divide. So whereby we say 4 divided by minus, that's plus 4 divided by minus is minus 4. Then minus x divided by minus is plus x. So now let's impute the value for x in the table of value. I would love us to repeat the same values. So our x is going to be the same as minus 2, minus 1, 0, 1, 2. So the value I'm using for my equation 1 is the same I'm going to use for my equation 2. Now we're going to substitute the value for x in this equation. That's y equals to minus 4 plus x all over 2 to get the value for y. So now the first thing is when x is equals to minus 2. So our y is equals to minus 4, x is going to be minus 2 all over 2, which is going to be minus 4 minus 2 is minus 6 all over 2. So minus 6 all over 2 is going to give us minus 3. So now when x is minus 2, y is minus 3. Now we move to when x is equal to minus 1. So it becomes y equals to minus 4 minus 1 all over 2, which is minus 4 minus 1 is minus 5 over 2, which is going to give us minus 2 whole number 1 over 2. So we'll bring it here, minus 2 and half. Now the next is when x is 0, when x is 0. So we'll have y equals to minus 4 plus 0 all over 2, which is going to give us minus 4 plus 0 is minus 4 all over 2. So negative 4 divided by 2 is going to give us minus 2. So now when x is 0, y is minus 2. So the next is when x is 1 and 2, positive 1 and positive 2. So when x is 1, so we're going to impute it, y equals to minus 4 plus, so for x is 1 all over 2, minus 4 plus 1 is going to give us minus 3 over 2. So now negative 3 divided by 2 is going to give us minus 1 whole number 1 over 2, which is when x is 1, y is minus 1 and half. Now the last is when x is 2. Now y equals to minus 4 plus 2 all over 2, which is going to be minus 4 plus 2 is minus 2 all over 2. Now minus 2 divided by 2 is going to give us minus 1. So when x is 2, y is minus 1. Now we've gotten the table of value. So this is the table of value. This is the table of value for equation 1 and equation 2. So what we're going to do now, we're going to take this table of value and impute them on the graph. So I hope you're ready with your graph, your pencil and your ruler. So now we're going to take this table of value and put them on the, let me not use put, and plot them on the graph. So now let me show you how to plot this on the graph. So on this graph, we have the table of value which we just got now. So we're going to use it to plot this graph. So now we have to take note of where is our y-axis and where is our x-axis. So what we call the y-axis, these are the vertical lines. The vertical lines are what we call the y-axis, while the horizontal line are what we call the x-axis. So now we have to plot this graph now. Let me erase this. So now that we've known the x and the y-axis, another thing we have to take note of is the highest value for each axis. So for y-axis, if you take note of equation 1 and equation 2, you know this is equation 1, this is equation 2. So for the y-axis, the greatest number here is 5. That's positive 5. Because even on equation 2, we do not have any positive number here. So the greatest number for y-axis is 5. Now for x-axis, the greatest number we'll have is positive 2, which is also on the second equation. Now among the negative numbers, the greatest for y-axis is minus 3, which is also on the second equation, minus 3. Then for x-axis, the highest negative number, that's the negative axis part, is minus 2, and then we'll have minus 2. The reason why I made us take note of the highest and the lowest number is because we have to know the origin. So let's assume this is our graph, then I want to actually get this part. So this place where the two graphs meet is the origin. We call this our zero origin. Then for y-axis, you know this is y-axis. The numbers, positive numbers are going to be up here, negative numbers are going to be down here for y-axis. Then for x-axis, the positive numbers are going to be at the right, then the negative numbers are going to be at the left. So this is the purpose of taking note of which number is going to be higher and which number is going to be lower, so that we can know how to get our origin. Are we going to draw the graph into equal parts? Are we going to, as in, put it at the, the y-axis should be bigger than the x-axis, or let's just get into it. So now we have our 5. So now let's count the graph here. This graph is actually 1 centimeter to represent 1 unit. I'm going to be working with a scale. I'm going to be working with a scale of 1 centimeter to represent 1 unit. So from here to here is 1 centimeter, and it's going to represent 1 unit. 1 unit means if this place is 1, this place must be 2, this place should be 3, this place should be 4, this place should be 5. This is what 1 unit means. But if I say 1 centimeter to represent 2 units, you know this is 1 centimeter. So it means if here is 2, this place is going to be 4, this place is going to be 6, this place is going to be 8. So this is what it means to say a graph like 1 centimeter to represent 1 unit or 2 units. You must take note of your scale. So for this scale, I'm going to be working with it on both axes, both for x and y axis. For this scale, I'm going to be working with both my x and y axis. So it is going to be 1 centimeter to represent 1 unit. Now we've actually understood every concept we need. It is now time for us to plot our graph. So I want us to count. Here we're going to have, let's say we have here to be 5, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3. Yeah, I think this would actually work because the highest number is 5 and it is here. It actually contains 5, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3. It contains. So I want us to work from this part. Now I'll get my ruler and also my pencil. So I'll be working with this part. Now we'll draw a straight line. It must be straight. Let me set the ruler well. Okay, so this is it. Now getting our pencil, we are going to draw a straight line. From here, we'll take it down. So I'm going to, after getting for the y-axis, I'm also going to draw the same for the x-axis. So now let's set our ruler for the x-axis. So let's count again. We have 5, 4, 3, 2, 1, 0. So this place will have 0, which is the origin. It's going to be where we are going to draw our line for the x-axis. So place our ruler there, and then we'll draw the straight line. So now that we've drawn the line, we can actually remove the ruler. We can actually keep the ruler aside. So the next thing we have to take note of here is numbering our graph. So remember, this is our y-axis and this is the x-axis. So now we have to number this graph. So I'm going to use 1. So this place is going to be 2. Here we'll have our 3. Here we'll have 4, and now we'll have 5. So we'll come to the negative part of y-axis. We're going to have -1, -2, -3. So after we've done this for the y-axis, we're going to do the same for the x-axis. So here we'll have our 1, here is our 2, here is our 3, here we'll have 4, here we'll have 5. Let's stop here. Now let's go to negative part. -1, -2, -3, -4. So let's stop here. So now remember, we are using 1 centimeter to represent 1 unit. So each centimeter here is 1 unit. -1, -2. Then we'll have here to be our origin. So this is our origin, which is 0. 0 is the origin. So now the next thing we're going to do is to plot this graph. Now let's plot the graph. So I'm going to be plotting for equation 1 first. I'm going to be plotting for equation 1 first. So what this means is, whenever x is -2 on the graph, y is going to be -3. So when x is -2, y is going to be -3. When x is -1, y is going to be -1. Let's plot the graph. The first one here says when x is -2, y is going to be -3. So now x is -2. This is where we'll have x to be -2. So now we're going to trace it to when y is -3. Now, if we take this straight like this, when y is -3, this is it. On the y-axis, -3. So when x is -2, y is -3. So we're going to point this part. We're going to use an asterisk, or let's say a multiplication sign. Just use any sign. You can even use full stop. So when x is -2, y is -3. This is what we're going to put it. That's we're going to trace from -2 to -3. Now the next thing is, when x is -1, y is -1. When x is -1, y is -1. So this is x -1, and this is y -1. So let's asterisk that to -1. So the next one we'll have here is when x is 0, y is 1. This is the origin. When x is 0 on the x-axis, when x is 0, y is 1, +1. So when x is 0, y is 1. So the next one is when x is 1, y is 3. When x is 1, this is our x-axis. When x is 1, y is 3. Y, +3. This is it here. So we're going to put an asterisk there too. And the last for equation 1 is when x is 2, y is 5. When x is 2, y is 5. When x is 2, y is 5. So we have to trace it. Y is 5 when x is 2. So can you see it? When x is 2, y is 5. Put an asterisk there too. So now we have been able to plot every value on equation 1. We have been able to plot every value. So the next thing we have to do is to draw a straight line. We have to draw a straight line. You can use your ruler, but I'm going to be using a straight line tool now. We're going to draw a straight line to connect the dots. We're going to use to connect 1, 2, 3, 4, 5, the 5 dots. So now this is a straight line. From here, it must be very straight so for us to be able to get what we're looking for. Very straight. So let's keep it this way. So this is it. Now the next thing is to plot equation 2 on the graph. The next thing is to plot equation 2 on the graph. So now for equation 2, when x is -2, y is -3. So when x is -2, y is -3. X is -2, y is -3. Now let's use, I'm going to use a full stop to denote this. So this is it. Now for the next value, when x is -1, y is -2.5. When x is -1, y is -2.5. So 2.5 should be between -2 and -3. -2 and -3. So it should be half of it. So half of -2 and -3, that was where we get our half. So 2.5. -2 and half will be in the middle. It will meet -2 and -3 in the middle. So now we'll have when x is -1, y is -2.5. When x is -1, y is -2.5. It is going to meet here. So the next thing should be when x is 0, y is -2. When x is 0, y is -2. So it will meet here. When x is 1, y is minus 1.5. When x is 1, y is minus 1.5. Minus 1.5 should be in the middle too. Then the last one is when x is 2, y is minus 1. When x is 2, y is minus 1. So it's going to meet here. Remember, we're using full stop to denote this. So the next thing we have to do is to plot a very straight line. We have to draw a straight line to connect these dots together. We have to use a straight line to connect these dots together. So now the straight line, let me start from here. Now we're going to take it and trace the dots. It must be a straight line. Remember, you have to use a ruler. You have to use a ruler to ensure accuracy. So now, if you look at the graph, the green one is the equation 1. Let us write it. We have it to be 2x minus y equals to minus 1, which is our equation 1. And then the yellow line is the equation 2. Our equation 2 is x minus 2y equal to 4. I would love us to stretch this equation 1, equation 2. Let's stretch the line further. Let's stretch it. So something like this. Yeah, something like this. So now we have to find the solution of this graph. Let's go to the method and read what it says about finding the solution of the graph. It says, draw the graph. Number 2, draw the graph for both equations on the same axis. We've drawn that. Now find the coordinates, that is x and y values, where both graphs intersect. So where the two lines meet is the solution of this graph. Where the two lines meet is the solution of this graph. Now the last thing says, check your solution by putting this value into the original equation to make sure they satisfy them. So that's the last thing we have to do. So now we have to take note of where the two lines meet. Now looking at this, this is where they meet. They met here. If you look, the green line and the yellow line, they met here. So I'm going to circle this place they meet and call it, let's say, P, point, or you can use any letter to denote it. I just want to use P. So let's circle it. This is where they meet, and I'm going to call this P. So now let's take note of the value for x and y when they met. So they met here, and when they met here, x is minus 2. We have to trace the x and y axis. They met here when x is minus 2 and y is what? Y is 3. So they met when x is minus 2 and y is minus 3. X is minus 2, y is minus 3. So we have to trace the x-axis and the y-axis. So now, since we've been able to get this, and we'll call this our P, the solution of this graph is the solution of this graph is x equal to, remember x is minus 2 and y equals to minus 3. So if you want to put it in coordinates, you can say it is equals to minus 2, minus 3. Remember, for coordinates, this represents our x, this represents our y. So x is minus 2 and y is minus 3. So I want you to take note of the answer we got here when we are going to apply it in the second method. So now, but before we move, it says check if this is actually correct. That's, we should check for equation 1 and equation 2 if this, our answer, is actually correct. So now let's bring in equation 1. Equation 1 says 2x minus y equals to minus 1. What did we get as x? We got x to be minus 2. So 2 into brackets minus 2 minus, what did you get as y? We got y to be minus 3. It says is equals to minus 1. 2 times minus 2 is minus 4. Minus and minus is plus 3 equals to minus 1. Now, minus 4 plus 3 is what? Minus 1. So, minus 1 is equals to minus 1. So, our answer is actually correct. So, this is actually for equation 1. Now, let's test for equation 2 to see. Equation 2 says x minus 2y equals to 4. Now, x is what? We got minus 2 into 4. Y we got minus 3 equals to 4. Now, minus 2 times minus 3 is plus 6, which is equal to 4. Now, minus 2 plus 6 is what? 4. So, our 4 is equals to 4. Now, the answer for this graph, the solution we got in this graph is actually correct. The solution we got in this graph is actually what? correct. So now we've been able to check if this graph is actually correct, like if the solution actually satisfy the equation. So now let's move to method number 2, or we'll call it method B. So for method B, let us write the question back, the equation. It says 2x minus y is equals to minus 1. That's equation 1. And equation 2 is x minus 2y is equal to 4. Remember equation 1, equation 2. Now, for the first equation, what we're going to do in this method is to make x 0 first. That's whatever we do for equation 1, we're repeating it for equation 2, remember. So, equation 1, 2x minus y equals to minus 1. So now if I make x 0 here, I'll be able to get the value for y. And if I repeat the same thing for y, make y 0, I'll be able to get the value for x. So now, let's say when x is equal to 0. So now this becomes 2 into bracket 0 minus y equals to minus 1. So 2 times 0 is 0. So x is gone like that. Now we have minus y equals to minus 1. And what we are looking for is just y. So y is equals to 1. So now you agree with me that when x is 0, y is 1. Remember x and y for coordinates. So repeating what we did for x, we are going to repeat it for y. So now when y is equal to 0, now the question becomes 2x minus 0 equals to minus 1. So y is gone. Now 2x is equal to minus 1. So when I divide both sides by 2, cancel, cancel, the value for x becomes minus 1 over 2. So you agree with me that when x is minus 1 over 2, y is 0. So for x and y coordinates, So now this is for equation 1. Now let's go for equation 2. So for equation 2, we have x minus 2y equal to 4. So now we are going to repeat the same method. So when x is equal to 0, we'll be left with 0 minus 2y equals to 4. So x is gone like that because x is equal to 0. We are left with minus 2y equals to 4. Now divide both sides by minus 2, divide both sides by minus 2. Cancel, cancel. Y is equals to 4 divided by minus 2 is minus 2. Now we've gotten the value for y. Now let's make y 0. So when y is equal to 0, now we have to look for x. It becomes x minus 2 into bracket 0 equals to 4. So since y is 0, y will be eliminated like that. Now we're left with x equal to 4. So now for the coordinates of the first one is going to be when x is 0, y is minus 2. Now the coordinate for this is going to be when x is 4, y is 0. So now you see this value we got here, we're going to take it over to the graph. Now when we take it over to the graph, we can now plot. So now let's bring this to the graph. So now I've been able to bring the values we got in the graph. You can actually cross-check when x is 0, y is 1. When x is minus half, y is 0. Then when x is 0 for equation 2, y is minus 2. And when x is 4, y is 0. So which is also what we have here. Now, you can actually place it this way. Or use the coordinate means. For the coordinate means, it's going to be for equation 1, it's going to be when x is 0, y is 1, something like this. And then when y is 0, that's when y is 0, x is minus 1 over 2. Then for equation 2, we can use the same thing and say when x is 0, y is minus 2. And then when x is 4, y is 0. So you can use this way to represent the values, or you use the means I used above. You can use any method. So now what we're going to do now, we're going to plot this. So in the last graph, we've been able to understand x-axis, y-axis, how to plot the line, everything. So what I want us to do here, I want us to now plot the graph using the same scale. We're going to be using 1 centimeter to represent 1 unit. So now let's draw the straight line. Like I said, you are meant to use a ruler, but I'm actually using a tool to give us a straight line without a ruler. So you must use a ruler and not freehand sketch. So remember, this is our y-axis and this is our x-axis. So the next thing to do here is to number the graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Let me stop here. -1, -2, -3, -4, -5. And here we have -1, -2, -3. So let's stop here. So what we have to do now, we have to plot this graph. So for the first equation, when x is 0, y is 1. This is it here. When x is 0, y is 1. So when x is 0, remember the origin is our 0. So when x is 0, y is 1. I'm going to use a dot to represent this. Then the second one says when x is half, that is between 0 and -1. So when x is half, y is 0. So when x is half, half is somewhere here. Half is somewhere here. So when x is half, y is what? 0. So what we're going to do now, we have to draw a straight line to connect these two dots together. We have to draw a straight line to connect these two dots together. What we are going to do now, the straight line must not stop here. Like, it must not stop where these two dots is. We can actually, what, stretch it. We can decide to what? Stretch the lines. So now I'll be using a ruler to do this part. So let's set the ruler on the two lines. Now let's connect. Okay, so now this is for equation 1. Now we can remove our ruler and keep it aside. So remember to number your equation. This is equation 1, and what's our equation 1? 2x minus y equals to -1. Now we'll move to equation 2. So for equation 2, it says when x is 0. Equation 2 says when x is 0, y is -2. So when x is 0, which is the origin, y is -2. And this is where we'll have our -2. So let's point. I'm going to denote that with asterisk. So y is -2. So the next thing is when x is 4. This is our 4. So when x is 4, y is 0. When x is 4, y is 0. This is 0 and this is our 4. So we're going to denote that also. I'm going to also use an asterisk to denote this. So what is the next thing we have to do? We have to connect these two lines. We have to connect these two lines with our ruler. So after connecting this line, remember, you must not stop at where the point is. You have to stretch the line so that they can intercept. Because if I decide to actually stop here where the line is and then stop here, there will be no intersection. They will not meet. So whenever you're plotting your simultaneous equation graph and your two lines are not meeting, it means it is short. So you have to stretch it down a bit or up a bit so that they can meet. Now let's use our ruler to connect these 2 points. So now that the ruler have been placed well, now let's connect the two lines. So this is it, and this is it. So now I can remove the ruler. Now this is what we'll have. So if you remember what we did earlier for the first method, the line is actually meeting at where the other one met. It is meeting here. Which is exactly where the first one met. So now I'm going to circle this point of intersection. Let's call it P again. So now it is meeting when x is -2. It is meeting when x is -2 and also when y is what? -3. X is -2, y is -3. Now we can say the solution of this graph. The solution of this graph is x is what? -2 and y is what? -3. You can write them as a coordinate. S, y is equal to -2, -3. So take a look. when x is minus 2, y is minus 3. So don't forget to give this your graph a number it like equation 2, and equation 2 we have what? X minus 2y equals to 4. So there is no need for us to check this graph again using the fourth rule on method 1. There is no need because we actually got the same number. The graph is actually correct. We are just using another method so that you can work with whichever method that work best for you. Whichever method is perfect for you, whichever method you understand best, you can work with it. So there's no need for us to check, because even if we check, the answer will still fall in place. The answer will satisfy the graph. Now let's move to method number 3. That's method C. So for method C, we're going to be using what we call slope. I think you might have done that in physics and also mathematics gradient. So now let's have our equation. 2x minus y equals to minus 1, and then we'll have x minus 2y equals to 4. So we'll call this equation 1 and we'll call this equation 2. Remember I said we're going to be using what we call slope in mathematics, or gradient, where we say y is equal to mx plus c. So in mathematics, whenever we are working on gradient, we work with this formula where we say m is equal to our slope. So in this case, m is equal to slope. So we're going to get a fraction. It is going to be rise all over run. So even if you get a whole number, just do it all over 1 so that it will give you this rise over run. And then the c there, the c is going to be our y-intercept. That's where the line is going to be on the y-axis, where the line is going to be, or where the value is going to be, on the y-axis. Now, we are going to be working with y equals to mx plus c. Y equals to mx plus c. So before we start this, for equation 1, I want to work with equation 1 first. Equation 1, which is 2x minus y equals to minus 1. Let's make y the subject of formula. So if I make y the subject of formula here, it becomes minus y equals to minus 1 minus 2x. That's when plus 2x crosses equation sign. So our y is equals to 1 plus 2x. So I want the x to be first before the number. So it should be y equals to 2x plus 1. Remember, for the negative sign here, we actually multiply both sides. If we multiply negative here, it is going to give us a positive y, and the same thing is going to apply here. Remember, we did this for the first method in this video. So now what we're going to do next is to put the value, like arrange this now, the mx plus c. This is what it now looks like. That's why I say we have to rearrange this. That's, instead of writing 1 plus 2x, just write 2x plus 1. 2x plus 1. So therefore, the mx here represents 2x, then c represents 1. Now, if x and x, okay, now let me bring it up. So therefore, mx, which is equals to 2x. Please remove the x, so that you'll be left with m. Now, m is equals to 2 for equation 1. Then for value of c, the value of c plus c, and then we have plus 1. So meaning c is equals to 1. C is equals to 1. Let's call this m1 c1 because this is for equation 1. Now let's work with equation 2. So for equation 2, we have x minus 2y equal to 4. X minus 2y is equals to 4. So we have to make y the subject of formula again. So minus 2y is equals to 4 minus x. So divide both sides by minus 2, divide both sides by minus 2. Cancel, cancel. Y is equals to 4. I want to split this. 4 over minus 2 minus x over minus 2. I would love us to split this because we are working with m separate and c separate. So y is equals to 4 divided by minus 2 is minus 2. Then minus and minus. Minus and minus is what? Plus. Plus what? 1 over 2x. 1 over 2x is still the same as x over 2. 1 over 2 is still the same as x over 2. So I'm just placing that there so that we'll be able to get our m and c. So let's rearrange this. Y is equals to 1 over 2x minus 2. So therefore, you agree with me that our m2 is going to be 1 over 2, then c2 is going to be minus 2. This is what happened. M is going to be 1 over 2. This is our 1 over 2. Remember, this is mx. So the m is 1 over 2. Then c is minus 2. So we have a negative 2 here. So c is minus 2. Now let's take note of this. For equation 1, m1 is 2, c2 is 1. And remember I told you that the slope is going to be rise over run. Rise over run. So if you look at this m1, which is 2, we have to make it a fraction so that it will be rise all over run. 2 over 1. We have to make this a fraction. Now let's take these values. m1 equals to 2 over 1, c1 is 1, m2 equals to 1 over 2, c2 is minus 2. Remember, this is for equation 1, this is equation 2. Now let's take this value to our graph. So now we brought the value of equation 1 and equation 2 to the graph. So the next thing, we have to draw the x and y axis. We have to draw the line for x and y axis. So let's have our line. Please use a ruler. I will always advise that use a ruler. So now we'll have y axis and then we'll have x axis. So the next thing we're going to do is to plot this graph. So please, whenever I want to plot this graph, remember I said the C is y-intercept. C is y-intercept, meaning the value of y on the line. The value of y on the line. Then this m1, which is the slope, we're going to have a rise and run, rise and run, rise and run. I will explain that to you. So now that we've drawn the line, let's number our graph. Remember, this is the origin, 0. So we have 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. Let's stop here. So remember, we are using 1 centimeter to represent 1 unit on both axes. So the next thing I have to do here is to plot this graph. And remember what we said earlier, that the C1 represents what? The value for y on the line, on the graph. The value for y on the graph. Then the m1, which is our slope, we are going to have a rise and fall and a rise and run there. We're going to have a rise and run. I said the slope is equals to rise over run. So the numerator is the rise, the denominator is the run. So now let's plot for equation 1. So for equation 1, C1 is what? 1. So meaning the value of y on the graph is 1. So it's a positive 1, y-axis. Remember I said it should be on the y-axis. So this is 1 on the y-axis. So I'm going to denote that. So now M1 means take a two-step. Whenever you have a positive at the numerator. So I want us to take note of something for the slope. If we have something like positive or negative number at the numerator. So let me say all over 1, all over 1. So we are actually working with fraction. So if you have a positive number at the numerator, it means take a step, like take one step up, go up. But if you have negative at the numerator, it means take a step backward, take a step or 2 steps, like it depends on the number you have on the numerator. So if you have plus 2, it means take 2 steps upward. On the y-axis, takes 2 steps upward. So let's assume you are starting from here, take 2 steps upward, 1, 2. But if you are having a negative, minus 2, if you are having minus 2 means, let's assume the point is here for y, you have to take 2 steps backward, 1, 2. So if it is positive, you go up. If it is negative, you come back. Are we getting this? If it is positive, you go up. If it is negative, you come down. That is for the numerator. Now let's plot this graph. So we've said that C1 is 1. C1 is 1. Now we have to plot the M1. So which is 2 all over 1. So this means this is positive, 2 over 1. This means we take 2 steps up and then we move to the right side step 1. We move to the right side once. So it means if we have our C here, we're going to start from where the C is. So if this is our C, take 2 steps up, 1, 2. Now move 1 step to the right, 1. This is because we have 2 over 1. So it is rise and run. So rise twice, 1, 2. Now run once, 1. I hope we're getting this. Let's do it again. C1 is what? 1. Now M1 is what? 2 over 1. So rise twice, 1, 2. Run once, which is to the right, 1. Then we put our point here. So we put our point here. Now let's do it again. Let's do it again. Now I'm going to start from where I stop. I'm going to start from where I stop. Now, rise twice. 1, 2. Take a step to the right. 1. Because it is 2 over 1. 1, 2. Take a step once. 1. Like to the right. 1. So now let's note that. So now let's draw a straight line to connect these dots together. We're going to use our ruler to connect this line together. So this is it. This is it connecting for the first equation. So the next thing we have to do, we have to move to the second equation. But before that, please let's label this equation. So equation 1, we have 2x minus y equals to minus 1. Now for equation 2, we have C2. C2, remember we're starting with the C first. C2 is what? Minus 2. So meaning on the y-axis, we have to work with minus 2. So let's point that first, minus 2. On the y-axis, remember, on the y-axis, you have to work with minus 2. Now, the step we're going to take, we're going to be working with the M2, 1 over 2. It means from this place, take 1 step, that is rise once, then take 2 steps. So we have to rise once, then run twice, 1, 2. Because of the 1 over 2. Remember, numerator means to rise, means to go up. Then denominator, which means to run, means to go to the right-hand side. So if we have minus 2, we are starting from the C2, minus 2. So we have minus 2, we are going to rise once, 1. And then we are going to run twice, 1, 2. So let's do that. Now, after we've taken note of this, let's do it again. 1 over 2. So I will go from this place I stop. 1, I will go up once, and then I will run twice. 1, 2. So let's mark that. I will go up once and I'll run twice. 1, 2. So I think I will stop here. Then let's connect the lines with our ruler. We have to connect the lines together. So now that I've been able to do this successfully, let's remove the ruler. So if you look at this graph also, it's almost the same with, not even almost, it is the same with the first method and the second method. They met here. Well, let's circle it and call it P. So they met when x is minus 2 and y is what? Minus 3. So therefore, the solution of this graph, you know the normal thing we're going to write. The solution of this graph is when x is minus 2, y is minus 3. So if you want to write it as a coordinate, it becomes minus 2, minus 3. So I hope you see what I'm seeing here. When x is minus 2, y is minus 3. So we're going to write it as when x is minus 2, y is minus 3. Now this is the third method for plotting simultaneous equation graph, or plotting the graph of simultaneous equation. We can write our second equation here as x minus 2y equals to 4. Do not forget to label your graph so that your examiner or your teacher will be able to tell which graph you plotted. You know, I'm actually working with 2 colors of marker here, but if you're writing in your book, you're working with a pencil. So your teacher will not be able to denote which graph is for equation 1 and which line is for equation 2. So that's why you have to always label your lines. So this is for equation 1, this is also for equation 2. Label it, circle where they meet, then you can give it a letter, maybe P, A, B, C, whatsoever. Then you write that the solution of this graph is X is this and Y is this. So, and you should always remember to check your answer. Always check if it actually satisfies the equation given. So now we've worked with three methods, method A, B, and C. So I would love to know which method actually interests you the most, like which method do you prefer? If it is method A, method B, or method C, put it on the comment section. I would love to read from you. So just tell me the particular method you like most and why you actually go for that one. Is it because it is easier than the others? Is it because it is more interesting, like you love the twist and everything as in behind the method? So this is all for today's class. I believe you actually understood everything. If you have any question concerning this topic, simultaneous equation using the graphical method, if you have any question concerning this topic, you should drop it at the comment section. I will respond and give you the answer to your question. Give you the answer to your question. Thank you very much for joining me in today's class. Please, if you're joining us for the first time, please subscribe. Give us a thumbs up. That's to tell us yes, we are actually doing well, and see you in my next class. Bye.